Mr. Ainsberg here, and I want to go over the multiple choice portion to this practice test. Now, the reason why is the free response, it gives you all the work, and it tells you the concepts that are used to solve each problem, but yet for the multiple choice, you're just told what the right answer is. You have to kind of analyze multiple choice when it comes to AP statistics to figure out how do they create the questions, and even where are the trick choices. And so there's a lot of multiple choice strategies that we have to learn throughout this year to make us better at that portion of the AP exam. And so this video is meant to help you out with that. And so if we look at the first prompt, it says you record the age, marital status, and earned income of a sample of 1,463 women. The number and type of variables you recorded is. Well, if I look through this, you may want to go, hey, I'm going to look at the quantitative. But if I look at my choices first, I could really eliminate a lot of choices by determining which one's categorical first. And so if I look at it, it looks like my marital status is the only categorical variable. And so by doing that, it allows me to cross out 3 choices right away. So I go from a 20% chance on guessing to a 50% chance on guessing. And now I have to figure, okay, do I have 2 quantitative or do I have 3 quantitative? And just so you know that 3 quantitative is the trick, because the prompt does tell you that you have a sample of 1,463 women. And so just because you see a number doesn't mean it's quantitative. In this case, that number is actually the sample size. Your N equals 1,463. And so that was the trick choice. Someone who saw a number and just said, oh, there's a number that's quantitative, they would choose choice C. When really the answer is D. And so when you read these, especially when it's a practice test, is use it to start figuring out some of the multiple choice strategies. So now let's look at number 2. So let's try some of these multiple choice strategies. And we're going to look at number 2. Consumers Union measured the gas mileage in miles per gallon of 38 vehicles from the same model year on a special test track. This pie chart provides information about the country of manufacture of the model cars tested by Consumers Union. Based on this pie chart, what can we conclude? Japanese cars get significantly lower gas mileage than cars from other countries. Now, we're going to have to read through all these choices. And you may look at A, and I'm going to cross out A pretending I'm a student. I'm going to cross out A because if I look at the pie chart, well, Japan's slice is bigger than Italy, Germany, France, Sweden. So that statement doesn't make sense. So as a student, and by the way, this is right and wrong. But this is wrong. I'm going to cross it out because I'm going to go, hey, my slice for Japan is bigger than those other countries. So that doesn't make sense. And I'm going to come back to A. U.S. cars significantly higher, get significantly higher gas mileage than cars from other countries. So if you look at the pie chart, it's bigger. So I'm going to leave that one alone. Swedish cars get gas mileages that are between those of Japan and U.S. cars. Now, by the way, if I look at this one, is it between? You may go, well, it's not. U.S. is the biggest, Japan is the second biggest, Sweden's not. So you may go, well, I'm going to cross that out, which, by the way, this is a little bit of statistics humor. Notice I have the words between circled. So this is some humor here, because if you look at it, Sweden is between U.S. and Japan in the pie chart. Oh, stats humor is so fun. D, Mercedes, Audi, Porsche, and BMW represent approximately a quarter of the cars tested. Well, we were given no information about what the models were, so that's going to be gone. More than half of the cars in the study were from the United States. Well, that sounds true. So which is it, B or E? And in this case, it's because of what does the pie chart represent. If we read the prompt, it says the pie chart represents the country of manufacture. It does not represent miles per gallon. So, B is the trick answer. And notice it's the first one we read, because some students would go, hey, that's true, and they would boom, mark it down and move on. They wouldn't read the others. B is the trick answer because gas mileage is not the variable represented in the pie chart. It's country of manufacture, which, let me go back to what I did wrong in part A. Part A says Japan Japanese cars get significantly lower gas mileage. Well, wait a minute. We're not looking at gas mileage. We're looking at country of manufacture. So A could be gone. B could be gone. Look at even C. Swedish cars get gas mileages. Wait a minute. That's not what the pie chart represents. It's countries of manufacture. So C could be gone. What we don't know anything about what was a Mercedes, Audi, Porsche. We don't know anything about that. So D could be gone. Just by reading and identifying what the right variable was in the pie chart, I could logically cross out A, B, C, D, and there's my answer, E. You have to be very careful with the reading. And this is a very good example to get your brain to start thinking about, what am I looking at? What does the graph represent? And so we're going to move on to number 3, which will continue to use this pie chart. And I'll take in consideration, notice I've highlighted there that there are 38 vehicles. So here we are in number 3, and we're trying to figure out which of these bar graphs is equivalent to the pie chart in question 2. So if I look at that pie chart, I can see that U.S. makes up more than half of the cars that were used. The country of manufacture, the cars are used in this. And that's going to allow me to cross out choices A and C. Because U.S. is the only one that's over half. The next largest slice in that pie chart is Japan. And so A is wrong. Because it doesn't look like U.S. is the biggest. It looks like U.S. and Germany are the biggest, which doesn't make sense with that pie chart. And C's wrong, because it says there that Japan has the most vehicles. So that doesn't work. So now I need to figure out which is the answer. B, D, and don't forget there's an E down there. But I'm going to go ahead and try B and D and see if one of those is true before I even consider E. None of these. If I look at it, I'm going to keep in mind that there were 38 vehicles used in this study. And so in this case, I'm going to go ahead and say that, well, since U.S. makes up more than half, well, half of 38 is going to be 19. And that means that my bar for the U.S. has to be larger than 19, which means my answer is going to be B. So I had to logically think through that the bar graph, how does it relate to the pie chart, which means if I'm doing that, I need to know what was my sample size in the pie chart, and then go from there to look at the bar graph. So that was number 3. I'm going to try a different multiple choice strategy in number 4. I'm going to look at what we're trying to find first in the answers, then go to the prompt. So in this problem, we're asked the median earthquake intensity of the sample is blank. So I know I need to find the median. And the choices are 575, 6, 647, 870, cannot be determined. So I'm going to keep that in mind now when I read the prompt. Earthquake intensities are measured using a device called a seismograph, which is designed to be most sensitive to earthquakes with intensities between 4.0 and 9.0 on the Richter scale. Measurements of the 9 earthquakes gave the following readings. So there's my table, where L indicates that the earthquake had intensity below 4.0, and H indicates that the earthquake had intensity above 9.0. The median, okay, so now we know what we're looking for. So if I'm looking at median, I'm going to put these from least to greatest. Now, when you're doing that, you need to keep in mind, what do the L and the H represent? The L and the H represent measurements for L that are below 4.0. So those would be to the left of that 4.5. Measurements of H mean above 9.0. So those should be to the right of 8.9. Now, I don't know what their values are, but position-wise, I can put them where they need to be. They're at the extremes. They're at below 4.0. They're at above 9.0. So right here is the numerical order of those measurements, which allows me to find the median. And that's awesome. So if I just go ahead and count, I can see what the median is. But let me analyze these multiple choice. E cannot be determined. So some people might go, well, wait a minute, I can't add numbers and letters together. So I can't add those. They're not the same. So I'm going to cross them out. Or maybe you're thinking that the L and the H are categorical. You can't find the median. And so that's a small trick, not a huge one. The main trick is choice A of 575. Because if somebody were to completely ignore the L and the H and try and find the median, they would end up with 575. But I can tell where L is going to be because it's below 4.0. I can tell where H is going to be because it's above 9.0. So though they're not giving me the exact numbers, I can place them still in numerical order, which allows me to count the middle, and that's going to give me 6. So B is the answer to number 4. Question 5 and 6 refer to the histogram that we see below, and I'm going to read the context of it. It says, in a statistics class with 136 students, so someone tells me that 136 is important because that's your sample size. The professor records how much money in dollars each student has in his or her possession during the first class of the semester. So here's the histogram, and we're asked to find the percentage. So this histogram gives us the frequency. Our job is to change that to a percent. So find the percentage of students with less than $10 in their possession. So if I'm going to do this, let's try this out. I'm going to have to find a percent. So I'm going to take a numerator divided by my total. What I observe divided by the total. And I'm observing less than $10. So I'm observing that first bar in the histogram, that first bin. And so if I look at that, that number is a little bit above 60. So I'm going to say it's around 62. Well, what's my total? Well, that was given to me in the prompt. I was told that it was 136. So if I go ahead and take that and type that in, I'm going to say it's close to 50%. And by the way, I don't need to type it in because read the directions. The percentage of students with less than $10 in their possession is closest to. It's not asking for the exact number. It's saying which of these choices is closest to the answer. Now let's move on to question 6. So we're looking at question 6, which uses the same histogram as question 5. It's just now we're being asked to figure out which of the statements given to us is not correct, which means I need to find out which of these statements is false. So I have to read every single statement. And don't just stop when you find one that you think is the answer, because that could be the trick. Read all your choices, just to be sure. And so the first choice is telling us the histogram is right skewed. So is that true or is that false? Is that correct or not correct? And if I look at it, that is a right skewed histogram. So I'm going to cross that one out. The median is less than $20. Well, there's 136 people in this study, if you remember. So if I cut that in half, 68 to 69 position. So the 68th term is the 69th term. That's involving a lot of work. I'm going to put that one on hold. I'll come back to that one. The IQR is $35. We may be going, well, there's more work there. I'm going to calculate the IQR. I need to take Q3 minus Q1. So I'm going to put that one on hold. I'm going to look at D and E. Well, D says the mean is greater than the median. Well, we just said the histogram is right skewed. And when it's right skewed, the mean gets pulled into the tail a little bit because it's not resistant to outliers. So because A is true, I can cross out D as well because D is true. I mean, those are both correct based off of that histogram. The histogram is unimodal, and I look at it, that bin from 0 to 10 does have the highest amount of all the frequencies. So it's either B or C, which does involve calculation, so I need to be careful. Let's go to median. Because in order to find Q1 and Q3 to get the IQR, I need to get the median first, so I might as well do that. Well, I already said there's 136 people, so if I look at that, I'm going to cross it out because if I look at it, the median is going to fall in the n plus 1 divided by 2 term position. So if I take 136, add 1, I get 137, divide by 2, it's going to be at the 68.5 position. So that means it's going to be the mean of the 68th term and 69th term. It's going to be between those two. Which if I look at where the 68th and 69th terms are, well, there's 60 in the first bin. So that 68th and 69th term is going to fall in that second bin between 10 to 20. So I can tell you that one is in fact true. The median is less than 20 is a correct statement, which means the IQR is 35 is an incorrect statement. Now here's why. We cannot calculate the IQR. We do not know the exact numbers, the exact values of Q1 and Q3. We only know their bin placement. And keep that in mind. You don't know here, same idea, that if the bin from 10 to 20 contains all 17s. We don't know the values. We can only tell you the bin placements of them. So we can't give you the exact dollar amount. And so that's something to keep in mind there as well. Now let's look at question 7. We're told 40 students took a statistics exam having a maximum of 50 points. And there's a stem and leaf plot that represents the score distribution that we can see. Find the third quartile of the score distribution. So I have 45, 44, 43, 32, 23. So it looks like it's in decreasing order. So I'm going to keep in mind a couple of things they're telling me. The first thing they're telling me is that I have 40 students. So in order to find the third quartile, I'm going to need to find the median first. And remember, the position, not the value, but the position of the median is going to be, in this case, the 20th to 21st term in between those two. So I need to find the 20th term, and I need to find the 21st term, add them together, and divide by 2. And so I'm going to get 31 and 33, divide by 2, that's 32. So you can see in the stem plot here, that is the location of the median. Now keep in mind, it is asking us for the third quartile. So right away, any number that is equal to 32 or less in this case, because I can see the numbers are all changing in that stem plot, any number equal to that or less, I should be able to cross out. So just so you know, 32 I'm not going to use because that's the median. And by the way, I'm not going to use 23 because that is the first quartile. So that may be a trick. So 45, 44, 43. So I'm going to go ahead and I can count through to figure out where is the exact middle of the upper half of the distribution. And if I do that, I'm going to see it falls between 44 and 44, which really means that it is, in fact, 44. So that is question 7. No real reading tricks or anything like that, just some ways to kind of cross out answers as you go. If you know the median is 32 and you're trying to find the third quartile, you should cross out anything below 32. And that should help you figure out what the answer is going to be. So let's pick it up at question 8. In question 8, we're told the mean salary of all female workers is $35,000 and the mean salary of all male workers is $41,000. What must be true about the mean salary of all workers? Again, in that case, I have to read all the prompts and figure out which one is true. So I'm going to start at A and I'm going to work my way down to E. It must be 38,000. Now here's what is interesting about this one. This one you could consider to be a trick. If you take the mean of 35 and 41, you're going to get 38. So this one is the average of 35,000 and 41,000. That's not what the problem's asking. It's asking, okay, of all the female workers, of all the male workers. We don't know if you have the same amount of female and the same amount of male. So A is the trick answer. If you just take those two numbers, add them, divide by 2, you're going to get A, which is actually wrong. So you need to be careful, make sure you read the problem. And notice how I talked about with part A that we don't know how many female workers. We don't know how many male workers. Do we have more female workers than male workers? Do we have more male than female? We don't know. It must be larger than the median. Don't know about that one. I have to think about that. It must be larger than the median. Oh, hold on a second. How do you find the median? Well, you have to look at how many total you have, put them in least to greatest order, numerical order, and find the middle. Do I know how many we have? Do I know how many female workers, how many male workers we have? And no, I don't. We do not have enough information about what the sample size of men were and what the sample size of women were. And that's what you see, N sub men, N sub women, the sample size of men, the sample size of women. We don't know how many male workers and how many female workers there were. That could be any number between 35 and 41,000. Now that one sounds pretty good. So, because we don't know how many male and female, but we know the average of the female is 35,000. The average of the males is 41,000. If I were to combine them, it logically should be between those. I don't know where between those, but it should be. So let's look at D and E just to be sure. It must be larger than 38,000. Well, if that was the case, you would have more male workers. E says it cannot be larger than 40,000. Again, in that case, you would have more male workers, but we don't know which one we have more of. So D and E can be crossed out for the same reason that B is crossed out. There's not enough information about how many male workers and female workers to conclude B, D, or E as being true. So the answer is C. So there is question 8. Let's move on to question 9. So here we are in question 9, and when I look at question 9, that's a lot of words. I'm going to look at what's given to us first visually, and that is a two-way table. And question 9 says, what % of all small companies receiving questionnaires responded? So this one looks pretty straightforward, but I'm still going to read the prompt in case there's any information I need in either this problem or a future problem like number 10 that relates to it. It says the survey was designed to study how business operations vary according to their size. Companies were classified as small, medium, or large. Questionnaires were sent to 200 randomly selected businesses of each size, so that's 200 small, 200 medium, and 200 large. Since not all questionnaires in a survey of this type are returned, researchers decided to investigate the relationship between the response rate and size of the business. The data is given in the following two-way table. All right. Now what's interesting there that we need to keep in mind is they use the same sample size for small, medium, and large companies, and what they're trying to do is determine whether there is a relationship between the size of the company and the response rate to the survey. So what % of all small companies receiving the questionnaire actually responded? So let's keep that in mind. We're trying to figure out first what we're observing, and we're observing the small companies. So let me kind of do this. If I underline, what % of all small companies responded? So notice I'm in that small company row, and I'm looking at the responded, and there's 125. So of all the small companies, 125 responded. So I'm also trying to figure out the total. So what % of all small companies? So I'm focusing on that row where it says small. Well, of all the small companies, there were 200. Of that 200, only 125 responded. So that's what I'm looking at in this case. I'm looking for the % of 125 over 200, which in this case is 62.5%. Now, by the way, even looking at it, you can see the response rate. This one's nice because it's 200. You have 125 over 200. You know that's more than 50%. So A, B, C, even D could be gone. It's something to keep in mind when you think about the logic of numbers. Is you can tell this is more than half that have responded from it, and it allows us to cross out. But the main idea is to get the reading down. What % of all small companies? So that's my total. I'm looking, okay, of all the small companies, which there was 200, how many of those receiving the questionnaire responded? 125. So keep in mind which row you're looking at and which column you're looking at. Are you looking for the intersection? So that's question 9. Now question 10 uses this same prompt, which is why I kind of read the directions for this. So let's continue on with number 10. So question 10 is asking us which of the following conclusions can be supported by the data. So in other words, which of these is true? And hopefully you realize there's been quite a few of these so far in this multiple choice. And the main reason why is to teach you to read. It's also meant to teach you that you can't just stop when you think you have a correct answer. You have to read through all of them because even the directions for multiple choice says choose the most correct answer. So make sure you kind of read through and go back to what's given you, whether it's a table or a graph, and go back to the prompt and just be sure you pay attention to the details. So we're going to have to read all of them and figure it out. So choice A says there are more small companies than large companies in the survey. Now I can cross that one out right away because both the prompt and the table tell me that 200 were used from all sizes, small, medium, and large. So that's wrong. Small companies appear to have a higher response rate than medium or big companies. Not sure about that one. I'm going to have to keep that in mind. You know what? I'm going to do some calculations. I'm going to hold that one. Exactly the same number of companies responded as didn't respond. Now that's easy because all I have to do there is add up the response column and the no response column. And I could tell that not the exact same amount. I mean, the responses, there were 246 total responses, 354 no responses. So that one's gone. So far, I'm going to do calculations to determine choice B, but choice C I can cross out. D, small companies dislike large companies. It's not even what that survey was asking. It's not even related to what the survey is, so that's gone. If we combined the medium and large companies, so we're going to combine medium and large. So you can see small is in blue right there. We're going to focus on just the yellow right there, or the off-white. If we combine those numbers, their response rate would equal that of these small companies, their response rate. That means if I add the 81 and the 40, their response rate, how many responded, that would be 121. And so does 121 out of 400, does that equal the response rate for the small companies, which was 125 out of 400? And the answer is no, it doesn't. In fact, this one is true. The small companies appear to have a higher response rate than the medium or big companies. And I could tell that 125 divided by 200 is bigger than 80 divided by 200 and 41 divided by 200. So for problem 10, the answer is B. But going through and figuring out how they come up with their choices is really helpful. Going and figuring out how to eliminate answers in the long term is going to build your skill for the multiple choice exam. Now we have one problem left, and that is question 11. Question 11 has a lot of words, but I'm going to start with the last sentence first. It says, which of the following is not a correct statement? So I'm going to keep that in mind of the results from this experiment. So we are asking for which of these is not true, which of these is false. I have a box plot, I have a big prompt, so I'm going to have to read all my choices again. Well, that's occurred a lot in these 11, is having to read all the choices and find the most correct answer. So let's just go ahead and read and pay attention to what it's asking us in the details. So an experiment was conducted to investigate the effect of a new weed killer to prevent weed growth in onion crops. Two chemicals were used, the standard weed killer represented by the variable C, and the new chemical represented by W. So right away I can see what is represented here with the W and the C in the box plot. Both chemicals were tested at a high and low concentration level on a total of 50 test plots. So again, I can see low concentration here, high concentration here. The percents of weeds that grew in each plot was recorded. Here are the box plots, which is found is not a correct statement. Okay. So I could go right down and read my choices, but I'm just going to quickly look at the box plots, and I'm going to figure out what can I tell. I could tell it looks like all the medians are different. I could see that the ranges could be different. The new weed killer, W, with high concentration has some outliers, while the other ones don't. The one with the less variability, the tighter box plot, is the standard weed killer right here with high concentration. The one with the most variability, the most spread, is the new weed killer with low concentration. And I could keep going. I could say it appears that the new weed killer for low and high have approximately the same or close to the same IQR. I mean, I could keep going on this. And I won't write this all down or do that. I'm just going to quickly observe the quick things. Not the no details, but the quick ones. And so then when I read, I might be able to cross things out. So at both high and low concentrations, the new chemical W gives better weed control than the standard weed killer C. So at both high, so here's high. So does the high concentration W give better weed control than the high concentration C? And overall, if we look at it, I'm going to say yes. And the reason why is the median for high concentration for the new one is less than 20, while the median for the standard at high concentration is greater than 20. I could see that 75% to the left on the high concentration, that third quartile, it looks like 75% is less than, like say 26, while 75% is less than, let's say, 28 for the high, for the standard. So, I mean, overall, I'm going to say, yeah, that's true. Overall, it does appear to give a better weed control than the other one. So I'm going to cross that one out because that one appears to be true. Fewer weeds grew at higher concentrations at both chemicals. So both chemicals, that means new W and old C, fewer weeds grew at those high concentrations. So if I were to look at it and compare W low with W high, does it appear that the high has a lower amount of weed growth? And again, I can look at it and it says it does overall. It does appear it. What about high concentration for the standard? And you got that down here with C, with low concentration for the standard. And again, this one does have a lower number overall. I mean, the third quartile is even below the first quartile when you're comparing the two C's together. So I'm going to say that one even appears to be true. So I'm going to cross that out. The results for the standard weed killer are less variable than those for the new chemical. Now, that sounds familiar, doesn't it? I mean, I looked at the spread of all of these, didn't I? And said, hey, you know what? That high concentration of the standard weed killer has the smallest amount of variability, the least amount of spread. It had the smallest IQR. That one looks good. That one looks true. But wait a minute, the problem is asking me for which of these is not correct. So I have to cross that one out. I have to remember, I'm looking for the false statements, because that C, that's true. I observed that right in the beginning, but I need to remember which is not correct. So don't accidentally choose a true one when you're going through. High and low concentrations of either chemical have approximately the same effects on weed growth. Don't you remember when I looked at these, I said, hey, you know what? They all have different medians, that their minimums are different, their maximums are different, the IQRs are different. I don't think they have approximately the same effects. So I think D is false. I'm going to hold off because I just have to make sure that it's more false than E. Some of the results for the low concentration of weed killer W show fewer weeds growing than some of the results for the high concentration of W. Notice it says some of the results. So I'm comparing W to W here. Some of the results of the low show less weed growth than some of the results of the high for the W, for the new chemical. And that is true. You can see on this whiskers, it does extend a little bit further to the left. So some of them do. So that does look like a true statement, which means my answer is D, because that one is not correct. They all have different medians. Even the lengths of the IQR is going to be different for most of them. I mean, it might be the same for the two W's, but not all of them. So they all had different effects on the weed growth. So the main purpose of this video was to get you to realize how to read the multiple choice, because that's a skill in itself in AP statistics. How to eliminate answers as you go through. How not to fall for certain tricks as you're doing it. And this is a skill to develop throughout the year, so when it comes to springtime, you can enter that multiple choice exam with confidence.